So when any datagram received at the router, different tasks are carried out by the router. Okay, different functions are carried out by the router. The first is it will validate the header. Okay, it will validate the header. On which particular field? How it will validate the header? Header checksum, yes. It is okay. Header checksum, it will calculate the checksum and check whether the header is intact or not, because two important fields are in the header. One is address. Okay, so whether addresses are intact or not. Once the addresses are okay, then only it will take the decision. Then process options in the IP header. Okay, process different options in the IP header, because option tells whether it is strict routing, whether it is loose routing, because IP header length changes from 20 byte to 60 byte. Okay, 20 byte is the default header, 60 byte is the extended header, where 40 bytes maximum is the option. So if any option is there, it will check that particular option, and on that basis it will process. Then the destination address, it will check for on which particular interface you need to forward that particular packet. Then depending upon the destination address, it will check the entry in the routing table. Entering the routing table. Now we have to discuss how this routing table is and how routing table get updated, what information is there in the routing table, so that the packet get delivered to the particular destination. That we have to discuss today. Then important is decrement the TTL, because what we have seen is TTL is the life of the packet. So number of hops are limited. So every router will decrement the TTL, that what we have discussed. So this validation of this you will get when you capture the packet in the Wireshark and check the TTL field. Immediately you can understand how these things are happening, because once the TTL becomes 0, packet get dropped. Then based on the MTU, it will take the decision whether to fragment or not. Okay, if required, it will fragment, otherwise it will pass the packet. Because next interface or next network, if MTU is more, then no need of fragmentation. If MTU is less than the what? Datagram size, then fragmentation is necessary. On that basis, it will carry out the fragmentation. Once the fragmentation is carried out, what is essentially required is, because after fragmentation, header field gets changed. Which header fields? MF, okay, which is more fragmentation. DF will not change because it remains same. Offset will get added if at all required. Okay, and total length. So all these fields are changing. So for that, it is very much necessary to recalculate the checksum. So it will calculate the checksum and then transmit the packet to the next hop. Okay, last point is if at all it is ICMP packet, it will take the necessary action, because ICMP is again control message protocol, which are typically using ping concept. Okay, so on that basis, it will send the ICMP packet back, because the most important ICMP command what you are using is the ping. Okay, so for the ping you are getting reply. So that reply is either from the host or either from the router. So here, if at all ICMP packet is there, it will take the decision. That we'll discuss at the time of ICMP protocol. But currently, send the ICMP packet if necessary. Okay, so these are the different tasks carried out by the router. And after that, packet get delivered to the next interface. Then we have started with the different routing protocols: RIP, Routing Information Protocol, open source pathfinding protocol, and border gateway protocol. Okay, border gateway protocol. So there are two types of these. One is autonomous system, where all routers are interconnected. So when routing is within the autonomous system, it is called as intra-domain routing. When routing is within the autonomous system, means autonomous system to autonomous system, it is called as inter-domain routing. Okay, so there are two routings. One is called as intra-domain, another is called as inter-domain. Means if at all your packet get routed within the campus, we call it as an intra-domain. If it is going outside, we call it as an inter-domain. So there are different protocols for the inter-domain and intra-domain. So that we'll see. Intra-domain is distance vector, that is routing information protocol. Okay, distance vector is depending upon the hops, it will take the decision and forward the packet. So always it is try to find the shortest path. Always just try to find the shortest path. So here what we have discussed is graph theory is essential. In the data structure and algorithm, you have studied the graph theory. So if at all interconnected nodes are there, how the connection between one node to the leaf node, that how to find out the minimum distance is the graph theory concept. So when we discuss the algorithm, we'll see this, what exactly the significance of this in the graph theory. Then link state algorithm. Because here only it will take distance into account. Here state of the link, that is traffic and other parameters, it will take into the account. Okay. Then in the inter-domain, border gateway protocol, which is based on the path vector, Okay. Now we'll see the example so that you can understand how this routing is functioning, because that is very interesting part. Now you can see the figure where these are containing these tables. So that suppose A want to send a packet, to E. So here it will find that particular path that E is connected through C, so it will forward the packet to the C and then it will reach to the E, and that is the minimum path. Because what you can see here is there is another path, but which cost 9. Weight for that path is 9. There is another path, again it costs 9. But this is the path what is selected. This is the path which is selected. What you can see is 6. So definitely this is the less count, that's why this path gets selected. But how this routing table gets created? Okay, who will responsible for providing the information regarding this? Okay, who is responsible for providing the information regarding this? This is the interesting part. Okay, so what is at the initial stage we'll discuss, and then we'll see how the routing table gets updated. Got this? As here very simple diagram is there, so A and D are directly interfaced, that's why no need to find out. But to send the packet to the E, it will select the path through C, because that is the optimal path. Okay, now I'll move ahead. Now what you can see is this is the initial table. So A is having the information regarding the B, so it is at distance 5. A is having the information regarding the D, it is at distance 3. A is having the information regarding C, it is at distance 2. A itself, but it don't have the information regarding the E, so that's why the entry is infinite. The entry is infinity. Now after that what happens? After that what happens? So the process is called as exchange of table. The process is called as exchange of table. So all the routers which are in the network start exchanging the table. So what happens? B will exchange the table with A, D will exchange the table with A, C will exchange the table with A. So from B what it will find that E is connected at 3. So here if at all it will put the entry B 8, sorry 8, 5 and 3. Previously I had written it 9, so that was wrong. 5 and 3, 8. After that, when it received the table from the C, what it found? Entry of E with 4. So previous entry is there, so it will remove this entry which is of side and it will put the another entry. So basically routing table get updated after exchange of table. So every router will exchange the table. Okay, but when? What should be the logic for that? For table exchange, because that cost, it will create the traffic. It will create the traffic. So I need optimal traffic to have table updation. I need optimal traffic to have table updation. So every router exchange the table with nearby routers which are directly connected. So what should be the logic for exchange? It contains a path to node which other node wants. Yes, yes. But when to exchange the table is the question. Every router will exchange the table for updation of its own routing table. Okay, that is okay. But when to exchange the table? So there are two logics. One is periodic exchange. Means after every half an hour. For simple understanding, we'll say this. After every half an hour, all the routers will exchange the table. Okay, what may be the problem in this? Got the question? There should be some remedy, there should be some methodology, there should be some process for this exchange. Exchange of what? Routing table. So very simple process is periodic exchange. Very simple process is periodic exchange. And to avoid the heavy traffic, decision is exchange the table after half an hour. What may be the problem in this? Got the question? Response? Got the question? If node is broken, then network will update or fixed period. No. They decided that after every half an hour, router will exchange the table. So dilemma is what should be that period? Because this network scenario is completely dynamic. Okay, it is continuously changing. Okay, it is continuously changing. So yes, Sayangita, after half an hour is long time. So if I keep the timing very small, for that matter, 5 minutes. So both the things are there. If I keep the timing very small, if I keep the timing very large. If I keep the timing very small, it will create unnecessary traffic in the network. It will create unnecessary traffic in the network. If I keep the timing large, if at all after 10 minutes, there is problem with this router. But because of not exchange, this entry is there. So A is still forwarding the packet to E, and this link has broken. Okay, or this link is having problem. So unnecessary packet drop takes place. Unnecessary packet drop takes place. And after 5 minutes means nothing is happening in the network. Within 5 to 2 minutes, still router starts exchanging the table. That will create huge traffic because every router will start exchanging the table. And that table exchange is nothing but the packet that we'll discuss in the SNMP. But this will create huge traffic in the network. Okay, so this is the problem. Keeping this timing very small will create the traffic. Keeping this timing very large will lose the information, we lost the packet. Got the point? So in the periodic, decision of timing is the crucial because as it is dynamic, I don't know what changes are occurring in the network and at what instance. Okay, because of this information is not typically available, deciding this timing is a problem. Got this point? Okay, then what it will do is another method for exchange the table is called as trigger. It's called as trigger. Trigger means it will exchange the table whenever there is a change. Otherwise, no point in exchange the table. Otherwise, no point in the exchange table. If entries are as it is, after exchanging nothing will happen, it will create unnecessary traffic. So trigger means it will exchange the table only when there is a change in the table. Okay, and that will solve the previous problem. That will solve the previous problem, which is loss of information or traffic. Is it okay? So method is trigger based. Method is trigger based. Whenever there is a change, then only it will exchange the table, or otherwise not. Because in the periodic, timing decision or keeping the timing particular is a major problem. Up to this point, clear? Because books are not explaining this in the particular manner. They will only say that there are two methods for routing table exchange. One is triggered, one is periodic. But why this triggered has advantages over the periodic is not typically explained in any of the book. But still, from the complexity point of view, periodic is simple for implementation. Periodic is simple for implementation because it will not check anything, just exchange the table after time tick or after particular count is over. That becomes very simple for the implementation, but another problems are there. Okay, we'll move ahead. So in the distance vector, share its routing table with immediate neighbors periodically and whenever there is a change. Now I'll see how these things are happening. Now what you can see is this table it will receive from C, okay, and this is the A's old table. So it will compare the entry, it will compare the table. So it will keep these entries as it is, okay, and this entry it will modify. This entry it will modify. So this is low cost, this is low cost. But as these are the direct connected, no entry changes there. Only this entry gets updated here. And this becomes the new routing table for A after comparison. After comparison. So after exchange, it will compare the original table and received table, and from that it will keep the lowest entry. It will keep the lowest entry. It will discard the highest entry and modify the table. And modify the table. If at all cost is same, if at all cost is same, it will keep the old entry. It will keep the old entry as it is. Okay. So the receiving node chooses the row with the smallest cost. And if there is a tie, the old one is kept. This thumb rule. This thumb rule. Because as there is no change, why to update the table? Okay, why to update the table? If next node entry is the same, then receiving node choose the new row even though the new value is infinity. If next node entry is the same, it will keep the new row because from the next it will get the new and it will update that particular table. Okay. Now when to share the table? One is periodic, one is triggered. So node sends its routing table normally 30 seconds in the periodic update. So node sends a routing table and any time when there is change in its routing table. So change means after updation or failure in the neighboring link. After updation or failure in the neighboring link. Because we have to discuss two interesting problems, then you can understand exactly the significance of this. Then you can understand the exactly significance of this. Now this is the interesting problem. This is very interesting problem. Just check the figure, then we can discuss the things. What you can see in the first figure, all the three routers are connected. A is connected to B at distance 4 and it is connected to X at distance 6. At distance 6. So entry here is X is directly connected to 2 and through A it is 6. Through A it is 6. Now problem is this ring has broken. So A will put the entry infinite. A will put the entry infinite. But what it found here is that it is connected through A at distance 6. So it will update the entry. It will update the entry. Then again it will update the entry. Then again it will update. So this particular thing is called as looping. So whenever there is a packet for X, A will send it to the B will send it to the A will send it to the B will send it to the A will send it to the B. And eventually, after TTL, it will get dropped. But till that point, that packet will move here because of this dilemma. Because of this dilemma. And after a certain point, they will put the entry infinite and then eventually get dropped. Got the problem? This is typical problem called as two-node instability. This is a typical problem called as two-node instability. Because of old entries available there, it start updating the table. And that's why there is a limit on this count. There is a limit on this count. It will not go up to the infinite. There is a limit on this count. Understood the problem? Typical problem? Now, how to resolve this is interesting. How to resolve this? Otherwise, A and B start playing with that particular packet. A will send it to the B and B will send it to the. It will never reach to the X. As destination address is X, A found the entry in the table that it is through B. B found the entry in the table that it is through A. Okay. Because of this dilemma. So every time it will increase the count. Every time it will increase the count. Very interesting and typical problem. Now we'll see solution for this. So first is define the infinity count. So when the count of in the routing table becomes 16, it will say that it is infinite count. So it will not allow the count more than 16. It will not allow the count more than 16. So that looping problem at least get resolved up to certain point so that they will not update the entry in the table. So once it becomes 16, they say that it is the infinite so that they will understood there is no connection. Okay, second is interesting, which is called a split horizon. So current problem is all the routers are exchanging the table. It is typically called as flooding the table. Flooding the table. So split horizon will give the solution for that. So node will send only the part of its table through each interface. It will not flood to all. Okay, so it will not flood entire things. It will send only the part of its table through interface. So node B thinks that optimal route to reach X is via A. So it does not need to advertise the piece of information to A. Okay. So while exchanging the table, B will not exchange the table with A in which entries are through A. Entries are through A. So that will solve the problem. That will resolve the problem. Got the idea? So instead of exchanging entire table, it will exchange the table only entries which are not having that router entries. So if we take the complex scenario, instead of 3, if we take 5, so all these are connected. So this will exchange the table with A without this entry. This will exchange the table with this without this entry. This will exchange. So that will resolve the problem. That is called a split horizon. Instead of exchanging the entire table, exchange the entries in which that router entry is not available. That router entry is not available. So if B is having the entry, B's router is having the entry of many other things. So what it will do, it will omit the entry of A and other entry it will exchange. So A will keep the X entry infinite and then it will understand that it is disconnected. It will not update the table with B. So this will resolve the problem. Got the point? Understood? This is very interesting. This is very interesting. So split horizon will resolve the problem of two node instability. Split horizon resolve the problem of two node instability. Okay, B will have entry of X via A, no problem, but when A got the table, it will immediately drop the packet because X is disconnected. And as it found that entry is infinite, immediately packet drop takes place. So eventually B will come to know that whatever the packet I am sending for X get dropped. Okay, whatever packet I am sending to X get dropped. In the previous case, what happens? They start exchanging the datagrams with each other because of entry. But here only B will send it to the A. As there is infinite, no connection, it will drop the packet. So looping, basically looping gets avoided. Packet dropping is definitely there, but looping gets avoided. So split horizon Poisson reverse. So distance vector protocol, this DV is the distance vector protocol, is using the timer. And if there is no news about the route, the node deletes the route from the table. So node A cannot guess any, this is due to the split horizon or because of B has not received any news recently. So Poisson reverse is node B can still advertise the value of X through A, but as source A is having the infinite, it will as a warning, as a warning. So from the A, we will came to know that X is disconnected. Now more complicated problem. More complicated problem. This is called as three-node instability. This is called as three-node instability. Look at the figure and you will come to know how this will get resolved. So this is real looping. This is real looping. Okay, what you can see here is they start exchanging and it will remain here only. Okay, because of this count they start updating this. So now all the three are sorry, some message received from the Cisco. So looping takes place. So after A sends to B and C, but C is lost. After C sends to B, after B sends to A, and here the packet loop takes place. So resolving this is more problematic. Resolving this is more problematic. So three-node instability problem is there in the network. Three-node instability problem is there in the network because of this disconnection. Because of this disconnection. So only count will save. Only count will save. So here it is not guarantee that this problem will resolve in no time. But only thing is TTL will save this. And one of the reason why TTL is there is this, to avoid the looping. One of the reason why TTL is in place is avoid the looping. Okay, in most of the interviews and other, the question is typical. What is the use of that TTL field? What is the use of that TTL field? So this typical problem, which is continuous looping, because every time when the packet receives, it will decrement the TTL. Every time when packet receives, it will decrement the TTL. And when TTL becomes 0, eventually it will not send that packet to the next router. It will drop that packet. So further things are avoided. So further things are avoided. Got the point? Interesting? Okay, so what we have discussed is routing table are available with the router for taking the decision on packet forwarding. Routing tables get exchanged by the router either periodically or on the trigger based. On the basis of that, it will update the table and it will have recent information regarding the network. Okay. Third is there may be problem of two node instability. Okay. There may be problem of two node instability. To avoid this kind of problem, exchange of table uses the method called as split horizon, whereas it will not exchange the entries which are of own router, and remaining table it will exchange, and that will solve the problem. Next is another problem may occur, which is three node instability. Three node instability, and that eventually, as the TTL is the field which is deciding the life of the packet get dropped. Instability problem is mainly because of periodic exchange, is the question by Manasi. Anybody? Instability problem